Welcome to part 2 of our demonstration on generating a Claude Code context using Mermaid.js. In part 2, we will generate working code for the example that we created a context for in the first part. Let's quickly summarize what we accomplished in part 1. The document above is the overview of the subsystem we created the context for. It illustrates a sample workflow for a user registration. We define the following steps for our workflow. 1. Validate the input. 2. Check password complexity. 3. Check in a database if there is another user with the shared username and report an error. 4. Save the user registration in the database. 5. Send the user an email with a confirmation code that can be later used to confirm the user's email address. 6. Report any errors back to the user. 7. Write important events and errors to a log file. On the left, you will see the documents that we wrote to instruct Claude initially. These include instructions for code generation, our desired workflow, reference documentation, and a user registration Mermaid class diagram that will serve as our code model. On the right, you will see the documents that we had Claude Code generate for us, using the instructions we provided. These include a pseudo-code markdown file, which was generated by Claude, as well as a user registration workflow used for illustrative purposes. We are now looking at the pseudo-code that Claude generated from the step-by-step specification we supplied. Here you will see each sub-process broken down into subroutines that we will use to generate our workflow code. Although we will use the pseudo-code document to generate our code, we also had Claude create a workflow Mermaid flowchart to help visualize the steps in our process, including states and conditions. To guide Claude in creating our process, we created a Mermaid class diagram with properties and methods to use as a blueprint of the model we will be passing to our workflow. This concludes our recap of the items we covered in part 1, designing our Claude Code context. We are now ready to start generating our code. We will open a Claude Code WSL terminal in our project root. The first thing we will do is instruct Claude to always read our initialization markdown document when starting a session. So that Claude remembers to do this, we will use the hashtag shortcut, which is used to instruct Claude to write instructions to the Claude markdown file for the project. We type in always read docs initial when starting a session to familiarize yourself with our context. For our first prompt, we will tell Claude to generate the .NET solution. We can see Claude is indeed referencing the context we created as part of the process. In our .NET Markdown instructions, we asked Claude to always ask for the solution name before generating files, so that we could plug that name into the template we specified. We will specify commerce as our solution name. We will see Claude generate a to-do list outlining the next steps. Claude is finished creating our .NET solution, as well as the C# projects for the shared library, the unit and integration tests, and the console application. Claude has also issued the .NET build command against our solution and confirmed that the solution builds successfully. If we look at our file inspector on the left pane, we can see that indeed the project structure is exactly what we defined in our .NET Markdown instructions. Now that we have our solution successfully building, we will instruct Claude to generate our user registration model. We use the following prompt, and we make sure we add the user registration class diagram file as a reference in our instructions. Using Mermaid class's user registration markdown as a reference, create the user registration model class in the shared project under the Commerce, Shared, Models namespace. As in the previous step, we can see Claude has generated an updated list of to-dos, specifying the next steps to take in generating our model. Claude has informed us that it has completed the code for our user registration model, and that the solution builds successfully. Let's take a look at the C# class that Claude generated for us. We can see the property accessors match the defined properties in the user registration class diagram. If we look at our class outline in the left pane, We can also see Claude was able to determine the intent of our validate fields method in our diagram, without us having to specify explicit instructions. Additionally, Claude created an isValid email format helper for validating the format of the email address, as well as a validate password complexity helper method for applying password complexity requirements. Both methods were correctly scoped as private, while the validate fields method appropriately was publicly scoped. We are now ready to have Claude generate the user registration workflow. We instruct Claude with the following prompt, ensuring we reference the specific files we wish to use in the generation context. Using pseudo-code user registration markdown as a reference, generate the corresponding code in the .NET namespace commerce, shared, workflows. Use the .NET user registration model.cs as the object passed to the workflow execute method. We can see Claude is again generating a to-do plan for the code implementation steps. Claude is finished generating our workflow. Claude has informed us that it created helper methods in the code, and these should be familiar. These are the sub-procedures that were defined in both our pseudo-code markdown file and our Mermaid flowchart. Additionally, since we have not created our data access code or configured an email server, Claude is informing us that the database and email operations will be simulated. Let's look at our generated code. In the left pane, we can see a list of methods generated by Claude. We can also see that indeed our user registration model is passed in as the argument for the execute method. If we look at the generated code, we see something that sticks out. Claude has generated validation methods within the workflow, even though some of the validation methods are already included in the user registration model we are passing as an argument. This is duplicating code and violating the single responsibility principle. This is a great example of caveats you will certainly run into when using AI tools to generate code. As you become more experienced with creating contexts, you will find that additions to your instruction files are necessary. There is something else to consider as a strategy for AI code generation. We have the ability to proceed with our duplicitous code and generate unit tests for it. When our unit tests pass, we can instruct Claude on our intentions as far as reducing duplicate code and constraining responsibilities as much as possible. This lends itself to the familiar test-driven development approach. In our demonstration, we are going to proceed with allowing Claude to create the unit tests before we ask Claude to refactor. For our unit tests, we will simply ask Claude to write unit tests for our workflow. Claude has finished writing unit tests, running the tests, and making corrections to any tests that have failed. We can see that Claude has generated tests for validation, model state verification, and input validation. As mentioned, we have duplicitous code. Both our model and our workflow contain duplicate methods for verifying user input. We want our model to handle all the verification that is specifically related to the user input. Now is a good time to check our generated files into our source control repository before proceeding to ask Claude to minimize duplicate code. After checking in our code, we instruct Claude to remove the duplicated logic with the following prompt. You have duplicated logic in both the user registration model and the workflow when it comes to input validation. Let's refactor the code to put all methods responsible for validating user input into the user registration model. After letting Claude Code run a few break, test, fix cycles, Claude has informed us that all 33 tests are passing. Additionally, Claude has informed us that it adhered to the dry, don't repeat yourself, and single responsibility best practices. Looking at our refactored user registration model code, in the left-hand outline pane, we can see what we expected from refactoring. The validation methods are now contained in our user registration model. Looking at our refactored user registration workflow code, in the left-hand outline pane, we can see that indeed the validation methods have been removed. The first line within our execute method now calls the model validate fields method and returns early if there are any validation errors. We have successfully removed duplication. To confirm everything is working as expected, we will open our solution in Visual Studio and run our tests. As we can see, all of our tests are passing. Wait, there is one thing we notice if we look at our unit tests. The unit tests are testing the execute method, but the tests indicate that multiple combinations of user input are being tested. This is supposed to be a unit test. We would expect the workflow unit tests to test the workflow methods, disregarding validation methods that should be tested in the user registration model. It is important to not only refactor your code, but the associated unit tests to make sure they are testing the appropriate scope. We will ask Claude to refactor the code and test with the following prompt. The unit tests for the workflow are testing the validation of user input. Let's keep the scope of the test in the right place. Create unit tests for the user registration model and place the validation logic tests there. Keep the workflow tests confined to testing the workflow methods. After Claude has informed us that the refactoring is complete, we can see in the Visual Studio Test Explorer a new unit test class was created for the user registration model, and it now contains all the validation check tests. Our user registration workflow now has a lot less tests. The tests now focus solely on the execute method, and the only test concerning validation is one that appropriately tests the condition that the model validate method returns validation errors. Our tests are now correctly placed. You have now seen how taking the time to engineer a context greatly facilitates the process of code generation using AI tools. There would obviously be more to creating a working solution, such as scaffolding the database, creation of the data context, and creation of services responsible for reading and writing data. Additionally, we would need to create a configurable email service to handle confirmation emails. There is a lot more involved, but the code generation process would follow the same guidelines as we have outlined. The value is in creating the context for Claude. Spending a bit of time doing this allows us to create working code with just a few prompts. Taking the time to supply pseudo-code markup to Claude also keeps the most valuable part of your solution, the logic, language agnostic. With just a few modifications to the context, we could rewrite this solution in JavaScript, Python, TypeScript, or just about any other language. Thank you for spending your time watching this presentation. We hope you will take away some ideas that you can build upon to help you develop a strong context and maybe some valuable tips on code generation.